Welcome to homework.
All right, we've got to draw some dipeptides. The first one we have is phenylalanine alanine, right? So let's just draw the structure of those, and then we can go through the other ones more quickly, but I want to point some things out before we just start drawing things. So I'm going to draw phenylalanine. Oops. Okay. And now I'm going to draw alanine. And basically, we're just going to link these two, but we've got to decide how to link them, right? And the order is actually important here, okay? So this is phenylalanine, and this is our alanine, right? So we need to draw phenylalanine as is, but we need to replace this OH functional with our NH2 from our alanine, right? And that's pretty much how we're going to step through these other problems. We're just going to draw the original one that's on the left and then attach the other one at the NH2, where we're going to replace the OH with the NH2. Okay, so for phenylalanine dipeptide, just draw phenylalanine as typical, except for the OH. Where we would have an OH, we now have an NH. And this part's a little bit tricky, so we need to preserve the stereochemistry here, right? So we're going to draw a wedge to this NH, okay? And this is still going to be our OH here, right? So hopefully that makes sense. Stereochemically, we basically attached right here, right? So we can just kind of consider we rotated this and replaced that. I guess if it might be a little easier to see, although it's roughly equivalent, but if I drew it like this, maybe that would be easier to see. I'm not sure. The rotation, right? If I rotated that 120 degrees and attached it. Okay, let's continue. Next, we've got, where are we? Looks like we've got glycine and glutamine. It says GIN, but I'm sure it means GLN. Okay. So I'm going to start with glycine, and then I'm just going to attach glutamine directly to it. So hopefully that's all right. Okay, so that's our glycine. All right. Just have a bond. Our OH. Okay, or our carboxylic acid functional group, and then we will continue the glutamine, which is 1 carbon, 2 carbon, 3 carbon. Here's where we have the double bond to oxygen and the NH2. Okay. Next, we've got lysine and glycine. All right. So we can just start with lysine. Oops. And then we're going to have a 1, 2, 3, 4 carbon chain. 1, 2, 3, 4 carbon chain before our NH2. All right. And then instead of our OH over here, we'll have the nitrogen from our glycine. Now, in this case, there's no real worry about stereochemistry here just because we've got 2 protons there. So technically, there's no real need to draw that as a wedge. All right. Next up, we've got arginine and histidine. We've got the 1-letter codes. R is arginine, and H is histidine. All right. We can start with arginine. Okay, then we've got a 3 carbon chain. 1, 2, 3. We've got our bridging nitrogen. Okay. Okay, there's arginine. And we just need to connect this now to histidine. Right. And now we've got our imidazole ring. And there we are.